And I want you to press pause on the video while you guys work on 1 through 5. Okay, now that you've been working on this for a little bit, hopefully you put that you noticed the pattern was growing by adding 4 every time. Because you have to add one on each spoke. If you drew it here, maybe you started with a dot in the middle and then you made 4 spokes that had 4 dots each. And then if you wanted to be able to count them or know how many are there faster than counting them, oops, I do need one more there. You could look at what's going on each spoke, and knowing there are 4 spokes helps. Do I need to take 4 times 3, for example, or 4 times 4, or 4 times 5? And then there's always the 1 dot in the middle. So mathematically, you could do something like this. You could take 4 times 4 spokes and add the 1 in the middle and get 17, and that's the right amount. But if I want to be able to use the 5, then I might need to go 4 times 5. Actually, let me back that up. Minus 1 plus 1 equals 17. And this might seem really weird. Like, why would somebody put a 5 minus 1 instead of just a 4? And it's so that you can get a new version of this. If I distribute, I get 20 minus 4 plus 1, which actually turns into 20 minus 3, and I still get 17. So there's going to be 2 versions of the rule that we can write, and one of them will look like the top one with no parentheses, and the other one will look like the bottom one with parentheses. Over here on number 4 to check it, I should now be able to take 4 times 7 minus 1 and add 1 to get 25. That would be in figure 7. And obviously, some of you would have just done 4 times 6 plus 1 is 25. I could also do 4 times 7 without any parentheses and just get to a 28, but then I'm going to minus 3 to get back to 25. And it kind of looks like that one in red over there. So what could the rules look like so that I could plug in any number n if I needed the 10th figure, the 20th figure? One of the ways we could write that rule would start with a sub n, like we've been noticing. That's going to represent just any value in the sequence is equal to 4 times n minus 1 plus 1. And again, if you distributed that and you got rid of the parentheses and combined like terms, you automatically end up with 4n, a negative 4 plus 1, but now I'm just going to erase that and put that would be equivalent to minus 3. I'm going to be using both versions of this rule when we write arithmetic rules today. And I can tell you that in my second period class that I've already been working on this for a couple days, it's about a 50-50 split, whether they prefer the one with parentheses or without. Okay, so sequences like these dots and the other ones that we've been working on lately are called arithmetic sequences. And they're the type that always increase or decrease when each term goes up or down by a common difference, we're calling it. And we've been using D already to represent that, like when we were on our pair deck. And on this next one, if we want to be able to tell if something is arithmetic, we have to be able to find a common difference. So what is happening in between these numbers? The common difference would be adding 7. So we just call it D equals 7. And if we can find that number, it is arithmetic. In this one, though, it seems to be losing 8, then losing 6, then losing 4, and so on. This is not arithmetic if it's not consistently losing the same amount every time. And the last one, getting from a 9 to a 6 to a 3 to a 0, you're losing 3 every time. So the common difference is a -3, which makes it arithmetic. And if you want to just start abbreviating those to A instead of writing out the word, that's fine. Press pause on the video if you need to catch up. Now we're going to start writing the general rule for arithmetic sequences with no numbers, but all variables put in would look like A sub n equals A sub 1, which means we use the first number in the sequence, plus n minus 1, so always one less than the one that we are concerned about at the time, times the common difference. And that common difference can also go in front of the parentheses just as well as in the back. I do prefer it in the front, so every once in a while, if you see me writing it in the back, just know that it's kind of an old habit I'm trying to break. If you don't want to use the parentheses, what you end up with is A sub 0 plus n times d. This one will be more comfortable to some of you because d feels more like a slope. When we think about linear equations, it's what is it increasing every time by? And this A sub 0 could feel like the y-intercept, like the first number that you plot. But what's really weird is in sequences, A sub 0 is not visible. It is the number in front of A sub 1 in both of these. We're going to find it though. So first find the common difference on each of these. And if you look, it seems to be adding 5. So I start making like a little list sometimes of the things I know. I do know that A sub 1 is a 3, the first number in the sequence, but it asks me to find A sub 0. So if I back up 5 and take away 5 from 3, I get to a -2, and that is A sub 0. Now I'm going to just choose both. I'm going to actually show both rules. So A sub n could equal, use the first term in the sequence, which in this case, A sub 1 would be a 3, plus the common difference of 5, and then times n minus 1, and you just get to leave it like that. N should always be the variable in your equation. If you write the other one, you need A sub 0, which we found is a -2, and then it's just plus 5n, the common difference times n. Now for the last set of instructions to find A sub 15, you just have to plug a 15 in for n on either one of those. So this bottom one is a little bit easier to use. If I go -2 plus 5 times 15, that's a 75. So multiply first and get 75, and then add your -2 with it. And so the 15th term, which you can write like this, A sub 15 equals 73. And then, this is also the answer that was the goal. Like it said, write the rule. Both of those are correct. And then what is A sub 15? On the next problem, the common difference, it has to be found. It looks like it's subtracting 8 every time. So D equals -8 for our common difference. Then I can add 8 back on to 55 and get a 63. So now I know A sub 0. I also know A sub 1 is the first number in the sequence I see, 55 if I need it. I'm going to look for what's A sub 15 in a second, but I need my rules written first. The first rule would look like the first number, A sub 1, the value of it being 55. I don't want to go plus D this time. I want to go minus because it's losing 8. So I can go -8 and then times n minus 1. And just to kind of prove that you get the same thing, if you distribute, you get -8n plus 8. Put a 55 back in front of that, and you can see 55 plus 8 gets you back to that 63, which means the other correct version of the rule is 63 minus 8n. I kind of prefer this one. over this one that has the parentheses, but you'll have friends in other classes that are only using the one in parentheses. And then last, I don't want to forget, the value of a sub 15 means I just need to plug a 15 in here. When I take it times 8, that's 120. And 63 minus 120 on a calculator, if you want to check it, is negative 57. Press pause on the video if you need to catch up. And now we're on the back side. After these examples, you'll be able to work on the worksheet 8.2 for a bit. And then there's going to be a part 2 to the video that kind of starts at this section of the notes. So back up to here, we need to write the rule for the nth term. That means we're needing the a sub n rule. And then we're going to find the first 3 terms of the sequence. So it looks like I only know the 19th term of the sequence and that the common difference is negative 3. I'm going to use n equals 19 for the 19th number, and I'm going to use that the a sub n right now has a value of negative 45, and that the common difference obviously is negative 3. I have enough of these now to write down or to fill in anything I want to this version of the rule. So I'm going to write plus d times n minus 1. I'm going to plug a number in here and for d and in for n. Then I'll be able to solve for a sub 1. Just scooting that over a second. So now I'm going to actually erase a sub n and change it to a negative 45. That's the value. I don't know a sub 1. Oh, I can change it to minus 3 instead of plus a negative 3. So minus 3 for d. And then n right now is the 19th term. And now I have to follow PEMDAS and make sure that I do what's inside parentheses first to get an 18 there. And then rewrite this once if you need to. A sub 1 minus 3 times 18 would be, that's a 54. Actually, I'm going to back that up and put minus 54. So now I can add 54 more quickly to both sides and get 9 equals a sub 1. I haven't written the rule yet, so I still have to go a sub n equals 9 minus 3 times n minus 1. And I was supposed to write the first 3 numbers of the sequence. I already have a sub 1 is 9, but I kind of want to practice writing it in expanded form, which looks like the sequence with commas in the middle. And so that would be 9. And then I can start losing 3 every time. Sorry, that looks like an A. I'm going to fix it. 9, subtract 3 and get 6, subtract 3 and get 3. It only wanted the first 3 terms of the sequence. They need commas in between. So this is an answer, and the rule is an answer.